All right, RMS Algebra. Welcome to one final video for our remote learning phase here. We're actually going to wrap up just by reviewing that idea of simplifying radical expressions that we looked at yesterday as well. Yesterday, the video kind of highlighted looking at a simple square root, like the square root of 60, and being able to not use a calculator but just simplify that. So we would look at, well, really that could be viewed as 6 times 10, and then that can further be looked at as 3 times 2 times 2 times 5. So we've looked at all those values, and the reason I went down this time to the prime factorization, or the most basic factors that can't be reduced by numbers other than themselves and 1, was so that I could see this pair of 2's, because that lets me know there's a perfect square there. That's like saying, okay, we have the square root of 3 times the square root of 4, which is 2 times 2, multiplied by the square root of 5. I know the square root of 4 is 2, and the square root of 3 times 5 is actually 15. So I could simplify it just like this. And you can see other examples of that during yesterday's video. You can slow down this and look at it again. But those were the simple examples. What I actually got a few questions on from students were some of the more complex ideas that showed up on yesterday's homework. So let's look at something like the square root of 25x to the 7th. And this is actually problem number 11 from yesterday's homework. So this is kind of nice because 25 is a perfect square. So believe it or not, right away we can turn it into the square root of 25 multiplied by the square root of x to the 7th. I know the square root of 25 is 5, so I've simplified this quite a bit already. Now, with a variable raised to an exponent, remember, we really could break that up and look at it as x multiplied by itself a total of 7 times. By definition, a square root is a number times itself that gives you an outcome. So anytime I see a pair, I can take one of those out. So here, this is kind of like I've really looked at 3 pairs, or x to the 6th when I multiply that out, and the square root of that is x to the 3rd. That one lonely x gets left behind because it doesn't have a pair there, but essentially I just took this x to the 7th and turned it into x to the 6th times x. And because 6 is an even number, we can divide it in half, and that's its square root. So 5x cubed multiplied by the square root of x is our simplified form of the square root of 25x to the 7th. We can do that with other expressions as well. If we pick another one like 28 times the square root, it's all under the radical, so the square root of 28 multiplied by x to the 9th, y to the 6th. This one might take a little bit more work. We have to look at 28, which is not a perfect square. We also have to look at x to the 9th and y to the 6th as we work through this. Fortunately, y to the 6th is actually the easy one this time, because that 6 is an even number. I know the square root of y to the 6th is y to the 3rd, because y to the 3rd multiplied by itself will give me that. So right away, things get a little simpler under the radical here. If I look at the x to the 9th next, well, x to the 9th could be written as x to the 8th multiplied by x, or x to the 1st. And the reason that's helpful is because x to the 8th has a nice perfect square, or value that can be taken as the square root. So we can now say y cubed times x to the 4th times the square root of 28x. And now, don't forget about that 28. This goes back to yesterday's work that we had done, where we can take 28 and see if we can simplify it and to find a perfect square in its factors. So 28 can be rewritten as 4 multiplied by 7, and the x is still there. We could write 4 as 2 times 2, but since we see that 4 is a perfect square, let's just take its square root. So now we'll have 2 multiplied by y cubed by x to the 4th. Typically we write our variable terms alphabetically, so that would be x to the 4th times y cubed, all multiplied by the square root of 7x. Now some of you may be thinking, hey, this doesn't look a whole lot simpler than what we started with, and I have to agree with that, but that is the process of simplifying this radical expression because it's done a simplification under the square root where things did get quite a bit simpler. Let's continue by looking at another example. I think that really is the best way to get comfortable with these. So if we look at one that'll actually be from today's assignment, working with 20x to the 10th multiplied by y to the 5th, and we're taking the square root of that, we can do this in whatever order you'd like. We could do it all at once. It really is a matter of your comfort. So let's spread it all out into things that will work for us. So 20 can be written as 4 multiplied by 5. X to the 10th, well, that is technically something we'll call a perfect square, but if you want to see it, it's x to the 5th times x to the 5th, which is a pair that matches. And then y to the 5th can be written as y to the 4th times y to the 1st. All right, now pulling out all the square roots that we can, 4 has a square root of 2. X to the 5th times x to the 5th has a square root that is x to the 5th. Y to the 4th has a square root of y to the 2nd, and we can't do anything with y to the 1st, so we now look at what's left, which is the 5 that doesn't have a nice square root, and y to the 1st, which again, we can't really take a nice square root that'll have a whole number for our exponent or value. But what we have done is fully simplify this radical expression to get 2x to the 5th y squared radical 5y. Let's look at one last example just to really get you comfortable. So if we also take a look at the square root of 75x to the 8th y cubed, we can use the exact same process. We looked at the square root of 75 yesterday, and so I know it's probably a good idea to divide it up into 3 multiplied by 25. You may pick other factors, but you'll work your way down until you see that you have 5 times 5. So you'll get the same square root of that regardless. X to the 8th, again, that's x to the 4th times x to the 4th. And y cubed can be written as y squared multiplied by y to the 1st. Taking out all the square roots we can, we'll remove a 5. This whole pair has a square root of x to the 4th. Y squared has a square root of just y or y to the 1st. And then we're left with 3y inside our square root. So our final answer without any multiplication dots, just written next to each other, is 5x to the 4th y multiplied by the square root of 3y. This is a process that really can be done in a variety of ways. You'll notice that as I've worked, I've done it in different orders. I would suggest that you guys pick the way that is easiest for you. If you looked right away and you saw x to the 8th could be taken out as x to the 4th when you take the square root, take that out first right away. If you feel more comfortable breaking everything up, do it that way. This is kind of an advanced application of simplifying radical expressions. So you need to really find a way that works for you to help you stay organized throughout this process. You will use all these concepts as you work through the remaining portion of today's homework. If you have any questions, please take advantage of office hours or email me, and we'll get them straightened away. All right, guys, good luck.